All right, this is Algebra, lesson 8.4. I went over this briefly yesterday with everybody, just so that they could have seen it before. I will show you today what to do. Okay, here's the deal. What you guys are used to seeing is a quadratic that looks like this: x squared plus 4x plus 8. You are used to seeing a quadratic that looks like that. Okay? And in this quadratic, the first thing you do anytime I tell you to factor this is to do what? What's the first thing you always do? Look and see if you can pull something out. Can you? No. Once that happens, and you see that this is a regular old quadratic here with a leading coefficient of 1, in other words, it's just a letter squared, then you know it's going to look like this. And that's what you do. You set it up like this, and then we go through the process. What happens now, though, is that now there is a possibility that you're going to have a quadratic that is this: ax squared plus bx plus c equals 0. And that a means that it's a number other than 1. A number other than 1. It could be it's a bigger number, right? It could be 5x squared, 2x squared, whatever. It's a number that isn't 1. So here's what you do. Okay, so if I give you this question, let me find one here. We'll find one that they gave us here. Okay, 2x squared plus 5x plus 3 equals 0. So the first thing we're going to do is this. You look at this guy and you go, is there anything I can pull out of there? Is there any number I can pull out? No. Okay, because there is a leading coefficient other than 1, I don't get to just go like this. I don't get to. I have to go through the process of doing something. And here's what it is. We're going to erase the equals 0 for now. Here's what the process is. Before, when I had x squared plus 5x plus 6, what you used to do was you'd go, okay, it's going to be, when you go like this, you go, okay, this is going to be that squared, which is x and x, right? And then this is going to be here and here. So in other words, these guys here would multiply to 6 and add to 5, right? That's what we were doing. Right? That was the puzzle. Multiply to this and add to this. Here's the difference now. The difference now is that it is not that simple. There's one more step. We are not looking for what multiplies to 3. We're looking for what multiplies to 2 times 3. In other words, we're looking for the factors of 6 because it's this times this. So look for the factors of 6. The factors of 6 are 1, 2, 3, and 6. Here's the deal. Now, amongst those factors, which ones add to 5? 2 and 3 does. So I'm going to show you something here. Here's how you set it up. Here's the original problem. You leave that baby alone. You know that this is going to be this. You're going to split that guy up into 2. You're simply going to rewrite him in such a way that he's here now. It's 2x squared plus 2x plus 3x plus 3. All I've done is I've rewritten this in this format. You see that, what is 2x plus 3x? 5x. All I've done is rewritten it now in this way. Yes?
Isn't it 6? Last number?
No. You rewrite this, and this one gets split into 2. Just watch. I'm telling you that you're going to look for the factors of this guy times this guy. That's what you do. You don't change the number to 6. You just look for the factors of that. Now that we have this baby, that should look very familiar to you. You look at that and go, can I pull anything out of that? Nope. But what can I do? I can now group them. What can I pull out of 2x squared plus 2x? I can pull out a 2x. And that leaves me with x plus 1. And over here, what can I pull out of here? 3 plus 3 times x plus 1. Now what can I pull out of this whole thing? X plus 1 times 2x plus 3. And now I'm done. How do I know if I'm right? FOIL it. What is x times 2x? 2x squared. What is 1 times 2x? Plus 2x. What is x times 3? Plus 3x. What is 1 times 3 plus 3? Do you see how they're identical? Right? We've done it right. Let me give you another one. Just like I did yesterday, I'll give you another one. Here we go. You're looking at this. It is 5x squared minus 13x plus 6. Now, I'm going to do this one last one for you. I'm going to do this one for you again, and then I'll give you guys some to work on. So you're watching and paying attention. Okay? You're watching and paying attention. Here's the deal. Is that a quadratic? It is a quadratic. So the first thing you're going to do is you go, okay, can I pull anything out of this? Because on your test, what's the only thing I'm going to say? Factor. Ooh. Is there something I can pull out of all those? No. Can I just go like this? No, why not? Because there's a 5 here. Okay, that means that I now need to break this guy up into 2. That's what it means. As soon as you look at this and go, oh man, there's a number there, I'm going to break this up into 2. You're going to find the factors of, what is 5 times 6? What is 5 times 6? 30. So I need to find the factors of 30. What are the factors of 30? 1, 2, 3, 5, 6, 10, 15, and 30. Rainbow, 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 rainbow. There they are. Which of these two things here? Now notice this. We know it's going to multiply to a positive, and it adds to a negative. What multiplies to a positive but adds to a negative? 2 negatives, right? So here's the deal. What two numbers here? 1 and 30, 2 and 15, 3 and 10. Now listen, wouldn't 2 and 15, wouldn't that also maybe work? Because 15 minus 2 is 13. Doesn't that work? But they both have to be a negative. And so is negative 2 and negative 15, does that combine to make negative 13? No. What about a negative 3 and a negative 10? Yes. So I'm going to rewrite this guy. I'm separating this guy right here into negative, okay, I'll do it right, negative 3x and negative 10x. And I bring this down, 5x squared, and then plus 6. Now notice this, I want you to see this. I wrote negative 3x minus 10. Do I have them in the right order, so much so that they would be the best way to group them? No, because this 5, if I did this, all I could pull out was an x. Does that make sense? It's going to leave me with a problem. So it would be better if I was to switch these around and write negative 10x minus 3x, and now I can group them like this, right? What can I pull out of 5x squared minus 10x? 5x times x minus 2. And then what can I pull out of negative 3x plus 6? Now remember, the ultimate goal here is to pull out whatever is going to make it so that this guy here and this guy here are equal. So what can I pull out of here to make it be equal to x minus 2? Pull out a negative 3. If I pull out a negative 3, that leaves me with x minus 2. Does that make sense? Now I pull out x minus 2, and that leaves me with 5x minus 3, and we're done. Make sense? Long, little bit, but I think these steps are not too difficult for you. It's just a matter of getting used to the puzzle, right? All right, let me give you one. Let me give you one to do. Let's go 7x squared plus 29x plus 4. Work on that one. All right, so here we go. This is what you do. The first thing you look for is, can I pull something out of here when I say factor? Can you? No, there's no number other than 1 and no variable. Okay, so there's nothing. All right. I can't go like this because of that 7, right? If that was just an x squared, then I can, right? That 7's a problem. So now I need to find the factors of, what is 7 times 4? 28. The factors of 28 are 1, 2, 4, 7, 14, and 28. So there's my groups. What I'm looking for now is this. I need to pull this 29 apart so that it multiplies to a positive and adds to 29. Therefore, what two numbers does it have to be? 1 and 28. So I'm going to bring the 7x down, bring the 4 down. So I have 7x squared plus 28x plus x, right, plus 4. This is kind of a weird one. What can I pull out of the grouping here that I do? What can I pull out here? I can pull out a what? 7x. I'm going to pull out a 7x. That leaves me with x plus 4, right? And then what can I pull out of this? Look here. What can I pull out of here? A 1. I can pull out a 1 plus 1 times x plus 4. Do you see what I'm saying? Now I can pull out my x plus 4 times that by 7x plus 1. How many of you got that? Kind of a weird one. Good. Does it make sense now, though, how you can pull out a 1 anytime you want to, right?
Yeah.
Okay, yeah, totally can group it differently. That's fine. It still comes out to be the same, though, right? Yours will just be 7x plus 1 times x plus 4, but it still comes out to the same. Okay, let's try another one. Try this. This is kind of a bigger one. We'll see how you handle it. 3x squared plus 15x plus 18. Go for it. Okay, first thing we do is you look, can you pull something out of here?
Yeah.
Yes. Yes, you can.
But can you do it either way? Like, will it still come out to the same answer?
Yes and no, not really. If you're going to truly factor something, if you don't pull it out now, then you have a problem in that in the end, if you don't eventually pull out that 3, which you're pulling out here, then it's wrong. It's not fully factored. You know what I'm saying? Like some of you are going to end up with something like a 3x squared somewhere, and 3x squared plus what? Oh, but you can pull out a 3. So if you in the end you have 3x squared plus 9, you're like, oh, then that's not fully factored. I mark it wrong. Does that make sense? So again, how many of you messed that up? How many forgot to pull out the 3 in the very beginning? See, that's ridiculous. I told you you'd forget to do that. What's the first rule about any time you factor anything? What can you pull out? I told you you're going to do that. Can't wait to see it on the test. I can't wait. Pull out a 3 times x squared plus 5x plus 6. Sheesh. Now you can go like this. Now you can go, now that's a plain old quadratic with a 1 leading coefficient. So now you can go 3 times, and it goes x plus 3 times x plus 2, and you're done. How many of you got that? Yeah. Exciting. That's exciting. Totally ridiculous. Okay, well, here's another one. What about this one? Here's a good one. 3x squared minus 17x plus 20. What's the first thing you do, people? See if you can see if pull anything out. Before you go move on, see if you can pull something out. Now try this. Notice this. It adds to a negative and multiplies to a positive. You should know what that means. All right, here we go. So the first thing you do is see if you can pull something out. Because this one looks like you might. I mean, they're all big numbers, right? It looks like you might be able to. Can you? No, that's a prime number, so you're not going to be able to pull something out. Okay, can I go like this? No. So I have to go, okay, that means I got to split this baby up into 2. What is 3 times 20? 60. Factors of 60. There are a bunch. 1, 2, 3, 4, 5, 6, 12. No, 10, 12, 15, 20, 30, 60. A lot of them. Okay. What two numbers are going to add to, we all know these are the pairs, what numbers add to a negative 17? Negative 5 and negative 12. I'm going to want to put negative 5 and negative 12 in the order that's going to be the best fit to group. Does that make sense? So am I going to put a negative 5 over here? and negative 12 here. Does 3x squared and 5 fit very well? Listen, it's going to end up being negative 5x minus 12x. Agreed? I'm going to split negative 17 into those two. And I'm going to pull this down. So that gives me 3x squared and plus 20. Is this the best fit to reduce? No. So I'm going to go back and I'm going to rewrite it to negative 12x minus 5x. Do you agree that it's the exact same thing? I'm just moving it around, and I bring this down, bring that down, so I have 3x squared and plus 20. Now I can group them. What can I pull out of here? 3x times x minus 4. And then what can I pull out of here? Negative 5, and that leaves me with x minus 4. Right? Pull out x minus 4. And that leaves me with 3x minus 5. And I'm done. Yes, Sladen, Bubba?
When you pull them out, do you start off like pulling them out, or do you like wait till you addition?
You have to, but you don't, there's nothing to pull out of this. Of the whole thing, there's nothing to pull out.
The negatives when you're trying to find the common stuff between.
Yeah, I would do this. I would once you group them, I like to grab the negative too, so that I know what, I mean, you don't have to, but then it'll make it confusing when you pull something out that you have to add that negative to it. Does that make sense? But the way I do it here is the way I would do it. I would get used to doing it that way. Question?
I got the completely opposite of that.
What do you mean?
I got x plus 4 and negative 3x plus 5. Is that the same?
No, not at all.
Wait, did you pull out 20 and 3? That's how I did. I pulled out 20 and I negative 3. Well, yeah, because I got, like, one of them was x minus 1 and x minus 1.
Watch another one. Here's the deal. Here's another one that's okay. Here's the hardest one on the page. Actually, before I give you the hardest one that I'm going to give you, I'm going to show you something. 4r squared minus r plus 7. You're watching. Okay, you're watching. Can I pull something out of here? Can I pull something out? No. Can I go right here like this? Can I go straight to that? No. Why? Because there's a 4 here, right? There's not just a 1 there. So you're watching. This is something new. I'm telling you should watch. Let's go through the process. That means we need to split this guy up, right? What is 4 times 7? So I got to find the factors of 28. Those are 1, 2, 4, 7, 14, and 28. Do you agree? Okay. So I'm going to end up pulling that down, 4r squared and plus 7. And now that negative 1r gets split into two things. Well, which of these groups, 1 and 28, or 2 and 14, or 4 and 7, could you add together to come up with a negative 1? What could you put together that would make them come up with to be negative 1? There's 1 and 28. No matter what you do with them, is there any way to make that negative 1? No. What about 2 and 14? Is there any way to add those two together to make them be equal to negative 1? No. What about 4 and 7? Is there any way to add them? No. Remember, we are factoring these things, right? We are factoring these things. And if you can't break it down any more than it is, then it's a prime number. Does that make sense? It's prime. There's no... So anyway, this is prime because there's nothing else to pull out. None of our rules work. So now I'm going to give you the hardest one this is the hardest type of one I'll give you. And we'll see how many of you can get it. I'll be impressed. 10y squared minus 35y plus 30. Factor it. Okay, see how many of you remembered how to do this? Did everybody remember to do it? What's the first thing you do anytime I tell you to factor? Pull something out. Can you pull something out here? What can I pull out? 5. So we're going to pull out a 5, and that leaves me with 2y minus 7y plus 6. Yes? Am I ever wrong when I say that you guys, some of you are going to do this, and then you always do?
It's a bit like, I just got done putting all of.
Yeah, I know. 2y squared. Okay, so here we go. So listen, in the end, whatever we end up with, it's going to end up being 5 times something, right? I mean, like that 5's out here now. He's been factored. He's one of the factors. That 5 is a factor. So we're going to leave him alone for right now. Does that make sense? We're going to remember about that 5, but we're going to do work on this problem without him. Can I pull out anything else? No. Okay. Can I just go like this for the rest of it? No. How come? That 2, right? No good. Okay, so that means I'm going to end up having to split that negative 7y up, and I'm going to have to go, okay, well, what is 2 times 6? 12. What are the factors of 12? 1, 2, 3, 4, 6, and 12. Okay, what multiplies to a positive 6 and adds to a negative 7? Which of them? Negative 4 and a negative what? 3, right? Negative 4, negative 3. Which way should I put it? Should I put it negative 3y, negative 4y, or negative 4y, negative 3y? So we're going to end up going 2y squared. So what would be the best match with that? The 4, right? So minus 4y minus 3y plus 6. Do you see what I'm talking about? Now I can group them. Get rid of this. You won't need to get rid of anything on your paper. I'm just out of room. And what can I pull out of here? 2y times y minus 2. And then what can I pull out of here? Negative 3. That leaves me with 2y minus 2. And then I go y minus 2 times 2y minus 3. Am I done? I'm close. What did I forget? This 5 that we pulled out originally, you got to shove it in front. Now we're done. How many of you got that? Does it make sense? Does it make sense? Does it?
Yeah.
We're not done. We're going to do another one. That's right, buddy. We're going to do another one. See how you do here. Should I choose one that? Yeah, well, here's a good one. Well, let me see. Which one should I do here? Which one should I do? Okay, I like this one. Nah, it's too easy. Hold on. All right, fine. We'll do an easy one. Just to make you feel good. 2x squared. No, I'm not doing that one. That's right. I'm not doing that. We'll do this one. 4x squared plus 38x plus 70. Jonathan, the first step in every one of these problems is to do what? Oh. Okay. Again, this is just a matter of going through it step by step, knowing the rules of the game. Each one of these is a puzzle. Each one of these is a little game. Remember I talked about Sudoku? That's all this is. It's just a different game that's being played. And how well do you play the game? So first thing we always do is look for what can you pull out. Can I pull something out of each one of these? What can I pull out? A 2. Right? So I'm going to pull out a 2, and that leaves me with 2x squared plus 19x plus 35. Right? Okay. Can I just go right here to this? No, because it's not, because of that guy right there. Okay. So then I'm just gonna remember this too. You might listen. What you might want to do is if you find yourself forgetting that sort of thing, then just bring the 2 down every level you go. If you're okay with remembering this stuff, like maybe you have a red pen or whatever, you put a big fat star here so you don't forget about the 2, right? Because you can't forget. In the end, I'm telling you, some people on their test are going to remember to take the 2 out at the very beginning, and then at the end, when they write their answer, they're going to forget to put it down. Does that make sense? I'm telling you, somebody's going to do that. Because it always happens. So that 2 is out there. Here we go. I have to split up this 19. What numbers am I going to split 19 up into? Well, no. But what am I looking for? Just forget the actual numbers. What is the rule? The factors of 2 and 35, right? So 70. Whatever the factors of 70 are, it's going to have to add to 19. So okay, factors of 70. 1, 2. 5, what is 14? 14, 35, and 70. Did I get it all? Oh, I missed 7 and 10? Okay, let me go back and do that. 5, 7, 10, 14, 35, and 70. Okay, rainbow, 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 rainbow. Okay, what two numbers? Add to 19 then. What numbers will jive? 5 and 14. Okay, so which way should I put this? Should I go 5x and 14x like this? Will that jive the best? No. Plus 14x plus 5x plus 35 2x squared. Group, 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 group. What can I pull out? 2x. That leaves me with x plus 7. What can I pull out here? Plus 5 times x plus 7. X plus 7 times 2x plus 5. How many have you got? Oh, am I done? No. Who forgot to put the 2? Raise your hand. I told you it's going to happen. It's just going to happen on the test. I promise. It's going to happen. Even right here, that's okay. It's your first time going through it. On the test, it's going to happen. Got to remember that too. How many of you got that? Okay. Your homework. Page 496. 10 through, I'm going to shorten it, 21 even. Okay? 10 through 21 even.